Question 4. So I've labelled up the diagram to reflect the two weights that we have. The weight of the rod is at point G because it's a non-uniform rod, so that weight is there, and the weight of the rod is mg. And the rate we've also got the weight of this particle of mass of 5/2m, which is placed at B. So we're being asked to show that GD equals 5/2d. So if we take moments about D, so just imagine this seesaw where we've got G at one end, B at the other. So the moment, the anti-clockwise moment is going to be the distance GD times the weight mg. That's this left-hand side. And our clockwise moment is the distance D times the weight 5/2 mg. Now mg is a common factor to both sides, so they cancel, leaving us with GD equals D times 5/2, which is of course 5/2d as required. Now for part B, we've now moved the particle of mass to the centre of the rod. So that's the significance here. Now we're being asked to work out the magnitude of the normal reaction between the support at D. So we are going to need to have to be taking moments about C in order to work out the reaction at D. So doing it in the context of distances from C, our particle that we've moved to the centre of the rod, well, the centre of the rod is 2.5d from A, but given A to C is D, that is 1.5d from C to the centre of the rod. So that's important. Make sure you understand where that 1.5d's come from. The distance from C to G remains as is. So that was how did we work that one out? Yes, we've just worked out that GD is 2.5 lots of D. So from G to B is 3.5. So G to A must be the remainder, which is 1.5. And given A to C is D, C to G must be half a D. So again, quite complicated to work that out. Make sure you understand where that distance has come from. And G to D, well, we know that, we've just worked that out. That's 5/2d, which is 2.5d. So I think the trouble here is being happy with these three distances. From then onwards, it's pretty straightforward moment stuff. So the moments about C, we've got in the anti-clockwise direction, we've got the distance CD, which is 3d. Okay, so that's a half d plus 2.5d, so 3d times r, so that's the moments on the left hand side, and our clockwise moments are mg times half a d and 5/2 mg times 1.5d, which I've done over here. Now all three terms have d in common, so that cancels, and gathering up our right hand side lots of mg, we get 17/4 lots of mg equaling 3r. Divide through by 3, we get r equaling 17/12 mg.